Hello, everyone, and welcome. We are back once again. This week, it will be it'll be on schedule for sure. But for now, we're back. We're going to be doing some coding today. It'll probably start a bit esoteric and go from there. But hello, Tess. Hello, Key. Welcome. Checking in with the kitties, we do have Ember getting a bit of a snack there. We have Mason has returned to the pillow. I have moved a water jug out here, so Mason and Molly are investigating extensively and destructively. That from there. Beverage. Sky is on my lap currently. Getting back scratches. Get away from that. Fine. Oh, troublemakers. I will have to deal with that later. Later is now. Oh, but if you recall, last time we had a mysterious issue where the entity with the identifier 256, after sort of flooding the screen, would no longer be collidable. And what I discovered is that the collision shader was not actually completing. It seems like if there's too much work in it, that it just cuts off. Now, there's an indication that Windows will avoid a timeout by forcing a process termination, but that doesn't align with what I was seeing. Instead, it was just that the shader stopped, so it wouldn't complete the entire work group. So what I ended up having to do is a mess. And what we do is right here. So within a given, what's the terminology here? We're setting up our uniforms. Okay, we are creating a series of pipelines. And for those pipelines, we're setting up extra uniforms. So we create a series of uniform sets, a kind of a collection of variables. Those collections of variables are identical except for one. One of them gets changed each time. So we have a series of other buffers that are the iteration of the buffer. Those just carry, 0 through X. In this case, 0 through 40. We run this algorithm 40 times. So we load those as part of the compute list. There is a series of compute pipelines set up and dispatched as part of a single submission. So it does those back to back, which gets us back to mostly the performance area that we were at. So we're still clocking in at 120 frames a second here. And we will go up to our critical case here. This is the one where we were able to see it go wrong. So we can see collision is happening. We're at about 4,600 things right now. We definitely slow down during this, but we are seeing collisions properly happen. We're going to run the death ball over to this last one here. There is some choppiness, and that's something that we may have to address. Right now, the shader happens in line in the physics step, and that is a potential cost we need to be aware of, especially given that the next stage is another shader. We are going to need to do a couple of things to accommodate that, but hopefully we don't need to take any more significant measures with the handling of the compute shaders for now. We're going to have to do a little bit more anyway, but hopefully not too much. Beverage. I'm going to need to move that around some. Table infrastructure being changed. So we're going to let them all die off here. And we get back up to our full frames. Guy is sitting with me, and Ember, normally if a cat's tail is like whipping around, it usually means they're agitated. Ember kind of wags her tail like a dog. If her tail is lashing around, that usually means she's happy and excited. Which, in this particular case, Sky is still on my lap and Ember is on my shoulder. I think we lost track of cats. But that's causing Sky to grab at her tail and currently chew the very tip of it, which doesn't seem to be aggravating her yet. Let's see if we can spot a cat to put on the camera here, since Mason has left the bed. Oh, wow. They're all hiding out. Oh, we'll leave it there for now then. Oof. Ember camera disruption. Sky is flailing away. Sky does like to play with things like your classic kind of feather on a wand kind of stuff. The problem being is that both Sky and Mason are kind of catch and kill sort of cats as far as how they play, which means that they will grab whatever it is they're playing with and try to run off with it. Which generally means that the other cats don't get to have fun with it once they get a hold of it, and they will very aggressively go after it. For some cats, that's actually really healthy for them because it is that mimicry of their sort of ambush predator hunting style. So it lets them exercise that. But when you're dealing with multiple of them, having one kind of hog it from the others disrupts that sort of playtime atmosphere. Which is partly why I have so many different things in the play area, is kind of maximum options for different stimulations for their different personalities. Like, Ember really likes that TV. Sherbet will watch it intently sometimes and give a light bap to the screen, but Ember will actually hang over the top of it. And every now and then I just hear this like rattling drum solo behind me when she sees a bird on the screen and just goes at it. Okay. But, so we have 40 different instances of this. So we break the work up into 40 segments. Let's open this up here. So we have this lovely calculation here where we're figuring out how many different instances there are. Now, we're overkilling it, doing it the way that we're doing it. Yes, indeed, James, more segments. So we have 8 by 8 by 8 here, which I believe is 512-ish. Yeah. So we have 512 workgroup divisions. So these are going to be separate processes on the GPU. And we're going to do that 40 times. Our max entities is currently 20,000. We could make this a multiple or some fragment of max entities to be certain that it works properly. But for now, it is not. So this is functional. I do have concerns about some of the structure. One is looking at the avoidance shader that we want to make. We have some duplicated data, and that is our... where is it hiding? Where did I put that? It's not the iteration. Yeah, here we go. I don't know why I duplicated shader in that. But our collider data bytes here is actually information about the entities, their size and their positions. Just adding more information to what we track about these entities and moving this outside so that there is a singular location for this is where the entities are and this is information about them is potentially useful for us. We need to be cautious about how much information we stuff into it, but there is plenty of it that is just, this is where it is. Because once it's created, we don't need to worry too much about it. You're very hyperactive today, Sky. So we've got this one working again. The next one, and the reason that this would be useful to adjust is we have so many entities like this where it is just, hey, something about the collision of this entity changed. There are possibilities that we need to set it up differently, but a lot of those are not really concerns for us. If I was doing something like a fighting game, then there's fiddliness with the way that collision would work versus where we put things on the screen. You're being very tolerant of what he's doing, Ember. He has like the back third of her tail and he's gnawing the last inch. Like, it's mostly fur, but he's not really biting either. It's kind of the play nipping that you'll see them do. But she is being very tolerant. She is choosing to ignore what he's doing. Okay, but we have collision. Another part of why we want the collider data to be elsewhere is, I think I'm repeating myself somewhat, but the collider data is the same data that we need to do avoidance. So we may start there, is looking at ways to get the buffers and handlers for them outside of the the structure here. So we could create a type of service that is a provider for a buffer. We create that buffer, and so we set it up so that that buffer does its thing, however it gets its data. In the case of the collider data, it's going to do the same thing that all of these do, the entity avoidance and that kind of thing. It's going to do what those objects do and just act as a relay between entity create, or entity added, I should say. So whenever one of those happens, it detects it, adds the corresponding type of object in whatever structure it needs, and goes from there. That means we don't have to create a whole other data set that we're keeping track of, because again, this is the same. By making that the same buffer, it also makes it easier for us to share some of this logic. Because ultimately, what I'd like to do is have any time that we're dealing with iterations on the same data. So in the case of collision, we're looking at where the entities currently are as of the end of a given frame. Avoidance will do the same thing. So that data is the same data that we're operating on, and constantly sending it up to the GPU is wasted time. Every frame we would be saying, hey, here is that data, and every time we run a shader, we're saying, here is that data, we have to send it up. But if we make it part of the same batch here, the same compute list, then that data isn't moved around. So in the case of our iterations here, only the iteration uniform changes. This other stuff actually remains in place. So the collider data uniform is still on the GPU. And hey there, Toby. Welcome, welcome. Whereas in the output uniform is, in the debug uniform is. This one gets sent up. This one doesn't actually need to be here anymore. I could remove that. So all of the input output from all of these 40 iterations, that's all happening on the GPU still. And it's only at that one point in the frame where I retrieve the information that we have that extra communication. So at the end of the frame and at the beginning of the frame is when we're talking to the GPU with this compute shader here. Might be able to catch one for a little bit here. Sammy's kind of given Sky the side eye here because I think she wants to come sit with me, but Sky is effectively in the way right now. So in that way, I would want to be able to have the collider data uniform, essentially entity position information, available to us across multiple shaders, across multiple potential compute lists here. Ideally, we batch them all together because everything that operates on collider data uniform, it would be useful if they had that as part of their upload. So I might have a collision output. So for collision, I have iteration, but that can be universal. If I break them apart, I can just say, hey, this one either only runs on iteration 0, or it also breaks its work up by iteration. Most of them would benefit from that. Part of the reason that we're doing shaders is because we can break it apart. So I queue all them up, queue them all, words, I can word. I queue them all up together so that I minimize the amount of uploading that gets done throughout the course of the iterations. If the performance stays good for our purposes, fantastic. If we don't, we're going to need to look at a way to async this process. It's not a huge burden necessarily, but we're going to need to be cautious about it. Because what we would want to be able to do is say, run it on the GPU and fetch the result, but don't have the whole physics frame blocking to do that. When it's done, emit a message so that the rest of the process can run. To facilitate that, we'd probably need to fully shift our core loop over to like a state machine so that we can have that, like, we're on the start step. When start step is done, it emits a message which shifts the state. On and on. Oh, we just hit the physics step starts. And until the end of physics step, oof, cat moving. Beverage. But anyway, it's instead of having a sequential call out throughout the physics step, we would actually be breaking it apart and have the physics step kick it off. But the processing would just happen in the physics thread. It wouldn't be dependent on the actual, that one actual thing. Again, though, it starts to create synchronization issues. Okay. So I think that's going to be the first thing that we do. We are going to abstract our handling of buffer. Ugh. Wrists are all snap and pop. Again, computers and video games all my life, so no matter what, if I rotate my wrists, it is a constant pop and grind sound. Like audible from a distance. Okay, let's see here. It's not part of flows. Nope, not a new class. And we're going to have so it's likely to be up to an individual entity to know what is in the data in particular. Because what we want to be able to do is just get the data. And anybody that gets the data needs to know what to do with it. So that's pretty much what we'd have here. We could put an RID in here, but we should avoid messing with that. So in this state, the buffer needs to be able to encapsulate whatever logic is needed for changing it. So this has to be a consumer of general messages. Any other kind of buffer is going to be again, it'll be something that it handles itself in some way. Like a service might also be a shader buffer. Another service might be a shader buffer that is registered and gets interacted with as one if it needs to handle everything on its own. Otherwise, the buffer can handle it itself. But we get a byte array out of it. inside of it, it's going to have some sort of tracking and some sort of method for updating the buffer. We would want to update the buffer leading into a call. So we have a explicit update call. No, that'll be internal. We need a way to know when we want to update the buffer, because I don't want to mess with the actual buffer object until we're ready to. Which means we need to get it before we kick off the physics step. Like at the start of the physics step. Oh, let's look at our loop. Start, time passed, end step, invoke game steps done. Then our shader collision manager. So the world will get its kickoff, and we're going to get world steps done. And during world steps done is when we compute collisions. So this is a race condition that we'll have to deal with. We would need to make sure that we are handling things in the right order, which means we probably need a actual physics start. So we have a physics done message. But we also are going to need a physics start message. Because on game start step, we're always going to emit a physics done in some way. Which means... Oof. Yeah. So physics step is a weird one. Physics step happens, it starts before game step's done. And it ends after game steps start. Because it begins at the end of the loop and ends at the start of the loop. So the reason we would need a physics step start is that is an opportunity for everything that needs to do prep for the physics step to do that. And we would put it effectively here in this shader. When we're saying, okay, we're starting our collision process. We're declaring that it has begun, and we're doing it. It needs to happen before we actually kick off the shader. So this particular shader buffer would be looking for physics step start. And that's where it would be. We would always do physics step start here. world steps done only says not computing because we have the idea that the physics computation can take longer than a frame. In theory, it could. If we decouple it so that it is purely a state-based series of events, then we still don't need to worry about this. In that the state at the end of the game step, and ultimately before the game step begins, is the physics step. That is, we are at the end of it. So when the physics step begins, we are kicking off the shader. So first, we have the kind of data prep where everything that has data for physics needs to update itself. Then we run the actual calculations, which will draw from that information. And then we wrap it up, which is largely the call to begin the next step. We are kind of in a what to start first moment. And I feel like the next one is just to get our physics step start message in place so that the shader buffer can be put in place. We update the collision shader to use the shader buffer data providers here. Which will have type extensions. Oof. Now, what you are witnessing right now is simultaneously rubber duck design, where I am trying to talk through what's going on, but also the consequences of my entire design being in my head. And this being a solo project. So making the shader buffers means we are going to also need to have individual providers of types of buffer, because we want them to be services. Alternately, I could have them registered, and that there is a shader buffer manager, and the shader buffer manager manages them by identifier. The identifier becomes a magic string. You need to know what it is in order to get it. This is not out of the question. That could be handled twofold, is if you know what the type that you need is, you reference it as a like an enum. I'm still happy that I found the Canon ND here. It is, again, a little happier than the rest of the tracks in general. But I like it. You've got that nice cello undertone, some kind of light violin going on. Very nice. Distracted by the music. Okay, let's get that message in there then. Movement, don't need. Entity is going to need to be moved out of there soon. I'm not going to touch that now because it creates a huge change surface to move folders around. Messages, not entity. Oh, no, we are in messages. Okay. Physics. steps. AI emits physics. Ember has Ember, like Sammy, is prone to developing like one fishhook claw at a time, and it is always the claw that is the most load-bearing when it comes to sitting on my shoulder. For Ember, it is currently one on the most likely the left side of her left forepaw, which is the part that is furthest along my right shoulder. It is much pointy. Oh, let's get physics done over here for reference. What general messages? Start step message. Okay. Then we're gonna need a Ember has gotten off my shoulder, so I can type a little better. Make sure Molly is under my wheels here. Okay. Okay, then we register this guy. Recover a Windows 98 instance through network boot. Oh, that sounds terrible. Let alone that it's a Windows 98 instance. Legacy systems, man. Wait a minute. Okay, this is just the kind of baseline one. We can have our shader collider manager here. Ah, okay. Wait a minute. It's physics state. Collision Manager. Shader Collision Manager doesn't... Oh, okay. So let's see here. Physics state. I don't like how that's set up. Emits physics done. Emits physics start. I recently tried to rewatch the Higurashi anime, Higurashi When They Cry. I believe the Japanese title refers to, in specific to like the cicada cry of the Higurashi type cicada. I've described it as Groundhog Day, but with more murder. Horrible murder. But, so the original one is not available on any US platform that I could find. I believe most of them are available for streaming in Germany and South Korea on various platforms. Apple Store lets you purchase the last 2 episodes of the original and the first season of the second most recent story arc. Read as very, very, very little of the story, because you have the original anime, which covers kind of in fast forward much of the base story arcs, but none of the sort of subsequent story arcs after that. And there's just a lot of ground to cover, so I have resorted to picking up the manga, which still, it covers all of it, of course. The manga is I think, to what I have found, the closest recreation of the original visual novels. Now, I would go through the visual novels, but their art is terrible. Comparatively. Manga does a better job. Arc to arc, apparently the manga also uses different artists. So far, not so different that it is... Like, I haven't encountered a bad one, let's say. But I like the story. They create really... the overall feel of it and how each of the arcs start is very slice of life. You're very basic Japanese school in a small town. So you have things like combined grade levels, school clubs, that kind of thing. But very quickly it begins sort of the mystery element of it. And you have different series of events within the story and how they play out. Is neat. I like. So that's been fun. Though, like, the Kindle interface for searching through them doesn't actually have the order perfectly. So you need to, like, find that. Physics start up here. Don't have to do it this way, but I'm doing it that way because it'll bother me if it's in the other order. Okay, that should be working there. Okay, and then within the shader collision manager, here we need to invoke physics start. This and a new there we go. Okay, so this gives us an opportunity to catch this information. So I think we can simplify some of this. I'll have to look. No, we're still going to need to track a lot of like sub information. So let's make sure that we didn't break anything. Then we'll commit these changes as an interim. And away they go. We're just making sure that none of them survive the waves here. Okay, still working. Don't need you or you. Physics. I was curious. This is the pattern for defining the floor of a room. Is you set up an image where the opaque space is where you can move within the room. The avoidance logic for the walls in the definition of the walls is not currently perfect. This multi-pass thing that we have learned to do here is actually going to be useful for making this more robust. Because we don't have to worry as much about the amount of complexity of running through it and saying, well, for open space, this is how it works. For closed space, this is how it works, that kind of thing. We can just iterate on it each time and use a different shader for each step and deal with it accordingly. But in the same vein, we can have this data passed once, and it will sit on the GPU until we're done looking at it. The output file can, or the output data can sit with the GPU until we're done with it, which is a good thing, despite the fact that that logic only needs to run once periodically. Okie dokie. So we've got that in place. Let's push that. Then, okay, now we need to go in and let's make the buffer manager. Services, compute. Thinking about this, I still don't like it. We need a way to maximize abstraction of this without having a bunch of extraneous versions. Because what I'd like to do is have a interface for the various shader buffer types. So the entity one is a specific one, and it's always active. Like, you should always be able to ask about that buffer and get its data. Whether that be getting the actual buffer, which should be part of the interface. Click RID get buffer. If I put it this way, then there needs to be something that instantiates them. I could make them statics, but that still leaves us with the issue of when do they first get invoked? Because if we make them scoped services, it's going to be as soon as you ask for them the first time. That they're really going to show up. So we would need a clean location where we set up the buffers. So how to get them directly? Again, we could have an enumerated type here that is the types of buffers, but that creates a location where I have to go and set them up. These are the buffers. Alternately, we can have a series of them that are, this is an interface that exists purely to represent that particular type of buffer. I feel like we should have an identifier for them, but that identifier should still always be the right type of buffer, because the data that results from it is going to be assumed to be in a particular shape. Okay, that is justification for particular types. Great. So we don't need this guy. Them being shader buffers gets us this. They always have this structure. The individual types, though, are important in their own way. So whenever we get the buffer, we're getting an RID that represents a buffer type from the from our local render device. Getting the data is get me the raw bytes. Ideally, we're not messing with this as much, and we may be able to dodge that. But it gets us a location to say we need the bytes. We'll figure that out. So we could have an I. So we're going to make a buffer for entity information. Let's call it the entity position buffer. And this is going to have a public interface. For now, it will be get. Okay. So this is going to get data in the form of a structure that is going to be defined here. Strict struct. Entity position data is going to be the same thing that we need to define for this, which is shader collider data. So we're going to go to the definition of that. So this is part of the critical aspect here. So we're going to make this pretty much identical. Okay, for those that haven't seen it, what this says is when we are compiling, we are making that, we're saying that this structure, the memory layout of this structure is exactly what I am showing here. And that becomes important. Second, we gotta find that. Let's use Godot. I believe that'll work. That becomes important because on the shader, when we get that data, it needs to be in an exact layout. This needs to perfectly match what we give it. If this is not a perfect match, then the bytes that go into it will effectively result in scrambled data. Like, you know, if shape were not where shape is supposed to be, we might have one of the dimension floats stuffed into it, which is very different in a uint than a float. So what type of entity, what it collides with, is it currently collidable, where is it, what shape is it? This is all potentially useful information in other forms. So when we are displaying it, some of this information might prove useful. We need to... I'm going to need a way to propagate this information. I wonder if there's a good way to do what amounts to an include in a shader. That'll be research for later. For now, this is identical. We don't need to worry about that. In our entity position buffer, we define the entity collision data, and we're going to say a public span for entity position data. So what this almost universally is going to do in one of these buffers is, if I want this one, I want to interact with it by this usually. What this does, what we'll do in it is like this. Let's see, find cast. Almost universally what we're going to do is this. We will return a span that is created by doing memory marshal cast. We're saying take this array of bytes and overlay on that memory, and treat that memory as if it were a span of uints. So the exact same memory, treat it as uints. So we will, in memory, that is the same address space. So if we change the span of uints, we change the bytes. If we change the bytes, we change the span of uints. We don't have to reallocate memory. That is the important part, because some of these arrays are big. For reference, the one that we're setting up is 20,000 instances of this structure, which is this actually might be an issue. Well, for now, we're going to leave it alone. I think it will force it into 4 bytes, though. Anyway. This is 40 bytes in size. So then we have 20,000 of those. It's not big in the sense of like memory on your hard drive, but it's non-trivial in the sense of memory in the runtime and being loaded to the GPU. So we don't want to have a lot of these things sitting around. But what this will allow us to do is if we want to add more data to this for, say, like animation shaders later, we can do that. We can get that stuff set up. Boy, this will be useful to us. Exactly how is going to be tricky, but we'll see. Anyway. Shader collider. Okay, so now we are going to add new item. Class. Implements I entity position buffer. Actually implements entity position buffer. And in an entity position buffer, that implements shader buffer. And then in entity position buffer, it does not actually implement that anymore. It needs to implement the rest of it. Okay, and what this means in creating this, to get this, we need the local rendering device. Each buffer does not have a local rendering device. Something else will have it. So we may need to have other types of rendering device, but for the moment, what we're going to do is we're going to make the assumption that we can have one local rendering device and go from there. Is equal to new byte array, and that is going to be in size. Oh no, that's something we have to do in the creation of it. Right now we're doing it in ready. Where we're creating our collider data bytes, we create this here. So that means we have to do it in the constructor of our position buffer. Yeah, okay. Hey, Lunar, did I add the mix of potion crafting games and Papers, Please minigame where you're a smuggler yet? Not yet, Lunar. A mixing element might be interesting, though. One of the gimmicks, or like one of the thematic gimmicks, is that the power-ups are like product upgrades, at least initially, foreshadowing. And having an opportunity to say, well, I have these, mix them together as my choice, you know? Take that one and mix it with this one, what do I get? And it could be that you get something just amazing or just terrible. Generally, it would be just terrible for your build. Or just amazing for your build. That's the idea, is that everything should be good in its own way. Like, you should be able to look at it and say, I can see a circumstance under where in which that would be good, and that circumstance is what I am doing or is very much not what I'm doing. You see an opportunity, you make the choice to try to pursue it, and it either works for you or it doesn't. The core of kind of build up roguelikes, your deck building style roguelikes, is I have this opportunity, do I do? Okay, so then we're going to take our logic from here. Take that, we'll use it here. Entities times our data size, which we are referencing elsewhere. Where are we getting that? Okay, we can do Marshall size of, but what are we using this in multiple places? We are not. Marshall. And that is the size of the entity position data, which is that. Okay, so we are defining it to spread out across this much space. $20,000 entity position datas is how big it is. So then when we are getting the span, we are going to return a memory marshal cast from byte to entity position data. And we are going to pass in our entity position data. There. So this is going to get us a span of entity position data values that is overlaid on the same memory address of entity position data. This is useful because anywhere that we want to interact with this data, we interact with it as this sort of span. Except when we are updating the buffer. At which point we interact with it as a byte array. So we need to subscribe to entity position added. Let's move these. Processing. Okay, shader collision manager. Whenever we get an entity added, yeah, right here is what we need. So whenever we add an entity into the system, we need to create a corresponding object that is meant to keep track of it. Its whole point is whenever that entity is updated in some fashion, based on what this buffer contains, it is going to change that. We may end up just having this be entity buffer and have the data be more robust, but, you know, there it is. So then in on entity added, we're effectively going to scoop the information that this, the logic for this buffer out of the collision manager, and we're going to put it into this other service. Create a shader collider. We add that collider to the collections here. Add its entity. We update the data from the collider, which will be its shape information. And then we attach the corresponding events to it. Let's get that shader collider here. Where we previously had the information. We have events to track when the entity changes or is removed. Go to the implementation. change the entity. This is catalog information that we're getting. So this stuff is still relevant. Because we're looking for these pieces. Entity collision data is going to be very similar to its position. Yeah. So I think it's okay that the collider information, this will let us abstract some of this information. Don't really want it to just be collider, though. It seems like we're... Because it's not really just that it's a collider. We're also considering the position. We're saying that collidable is relevant because if it's at a spot but you can't bump into it, it's not really taking up the space in the same way. That will vary, but that is a consideration. We're including the shape because we could incorporate that into the avoidance data, where if an entity is in a position, we could mark everything within its collidable area as occupied space. Our first pass is just going to say wherever the entity is considered to be as a point. In general, that means where is the entity's center in the world. That will be our collidable point and will radiate avoidance out from that. But knowing its shape gives us information on that as well. So we are going to get collider data from the catalog. And we'll stick with it being shader collider data for now. Well, we'll move it into entity position data, and we'll use shader colliders inside of it in order to track them. So we're going to nest it a little bit. Okay. So we're looking in our compute, we're saying entity position. It's just a structure currently. We're creating a wrapper for that that's able to spit out shader collider data when needed. But this is not catalogable. This is its own thing. And at the moment, we don't really need an interface for it. This is an entity position. really necessarily like that, but here we are. Don't need JSON related stuff for this. We have our shader collider data, which we can emit. Doesn't need to be a virtual for this because we've got that object. So we're going to have an eye shader collider inside of it. Which emits the information that we want. Okay, so we have changed and removed on it. This is I believe this would just be sending an entity position. No, we need a specific message for that. It could relay an entity position changed, but it's not really the case there. Not an entity position update. This entity, where it was, where it's going. And this is the entity to remove, but it's not really an entity. We are actually saying entity data, or entity position is what is changing. And now this name is inconvenient. An entity position has an entity, and we could have an old and a new in the message. This message is potentially usable for this because we're not really ever saying when we get this message, we're getting it in general. We could, though, because we could just take the collider from there and use it that way instead of saying, oh, I got it from this particular one. In fact, that's what we're doing, is that we would be getting it, looking at it, and saying, this is the information that I need to know about it. Okay, when we have... we have a dictionary of them by ID. It is the entity that is relevant to this. Because it's not really the collider's ID, it is the entity. That is what we care about. So the entity's ID is the one that we're looking at for these purposes. So, this is entity position update message. Move entity message. is entity position data. So we'll have a getter setter for this. I'm sorry, we'll have a getter for this. Because that is a read-only field. Which is just return data. When we create one of these, it is always going to be with an entity. And we'll extract the relevant information from there. We don't actually need the collider after we initialize it. So when we're adding it, we're going to get our catalog, we're going to get our collider out of it based on the entity's collider key. Yeah. So we'll take the entity that we get, we'll get its collider, we're going to get the information out of that collider in order to set our data. Then we can get the collider data and add that into the collection. And then whenever it's updated, we just set that collider data equal to. Yes. So we're going to get this information when that comes in. We set the entity, we're going to use entity collider key here. So now we've got our collider key. We have that data. And in a entity collider. So this is the shader collider that we've got. And shader colliders have the idea of shader collider data. So for the time being, shader collider data is where we will get the information that we need. We may break this down further, but shader colliders still need shader collider data for us to get that information we need. So in an entity position, we're going to have we're going to do a bunch of data dots here. and we'll go through them in sequence. Is in our entity position buffer. We want to get it to line up here for consistency. It's a service, it's part of compute, it's part of this. So we have shape, dimension. We're just gonna get this whole thing. Data dot. Data collider is listening to the entity when it updates. But we don't want to be doing that. We just want to get the data the first time and handle the updating ourselves. So this will be a little bit messy. Okay, we'll think this one out a little further right after a break. Remember, folks, if you're liking what you're seeing, then remember to like, follow, subscribe, that kind of thing. It does help the channel. Be right back. And we're back. You see me. Okay. So we're gonna sidestep this a little bit. We're gonna get the shader data. We're gonna get the shader collider. We're gonna request its data. And then we're essentially gonna set it aside. We'll release the object and not do anything with it. All right, that camera is drifting down. We'll have to fix that later. But you can see Sky. Sherbet is behind him. Okay. So we're going to get all of this information. We get this information from the shader collider. Mason. Was over there crying. There, have some back scratches. Okay, so when we get loaded, we set the entity like this. We are then going to say that and we're going to get the initial information. No, we'll do it this way. Equal to collider dot data. Equal to collider data dot shape. What? One. Dimension 3. Okay. So that's the information that is relevant to the shape. And currently shapes don't change. Is it possible for them to? Yes, we'll get to that later. Right now, if they have a collision shape, it sticks around, and it's just that it activates or deactivates. If that's going to change, then collision fundamentally changes. So then when we update this data, we're going to say is equal to entity.category vision mask. We don't change the data pad value. Okay, so this is setting the initial shader data. We are going to have it protected, void. Slider data there. A little bit of further encapsulation. So additionally, we're going to be able to attach and detach events here. Void detach entity events. So it will be on entity collidable changed. Collidable position updated removed. This on entity remove. Just so. And then we're going to take these same things in detach events. We just do it. Hello, Molly. Come on, get comfy. Molly is my one cat that will do the whole kneading thing before she sits down. Which means her laying on my lap is that protracted, find just the right spot kind of cat laying down. So for the time being, in order to placate her, she's getting back massage. She doesn't need as much reassurance as some of them do. She will come and sit with me, but not nearly as often as Ember or Sammy. Often what she does is just sit under my feet, right next to the chair wheels, so I always need to check and see if there's a cat nearby. Minus, minus, minus. The position has updated and remove. If remove exists dot invoke sender and E. We detach events. We remove. On update, we do the update data here. Typing around cat. Exist.invoke sender in E. Same thing, we're just going to update data. Okay. So this will be the thing that we ultimately create. Come here. Come here, Mason. He's being very needy. Gets really squirmy. Come on. Can't reach that far, bud. He wants, like, you really gotta to work your fingers in back scratches and belly rubs. He's also taken to sticking his head right into the stream of the dehumidifier. So his forehead will often be kind of damp. Well, he says, you stopped paying attention to me. She is such a clumsy cat. She's definitely got some body fat. She's definitely a little pudgy. But she's one of those, like, stocky cats. You get a lot of cats that are real trim. Mason is currently playing with the dehumidifier. Previously, the dehumidifier was unstable enough that he could pull on it. He would try to tip it over. Luckily, he'd try to tip it over from the side that would cause it to bump into a table, so it wouldn't tip over. But I was worried about that, so two things. He wasn't really trying to tip it over, he was trying to pull it open, and he was able to pull the top off. The process for doing that would cause it to lean, though, and in concern that he would pull the whole thing over and spill the whole tank of water everywhere, it is doubly contained. One, there is duct tape acting as a hinge from the side that he doesn't pull on, so he's not able to pull it open. That does mean that he now has more leverage when he pulls on it, trying to open it, and it does cause it to tip a bit, but the feet of it are adhered to the surface with two-sided tape, so it doesn't move much at all. That does not stop him from sticking his face in the dehumidifier stream, though. It really seems like it's a convenient, like, bathing aid for him. Not as much licking necessary, you know? Can just use it as a quick soak. Yeah. Molly tends to be, like, nearby when he's doing it. Like, she's curious about the stream of it, but she doesn't pull at it. Anywho, okay. So then when the position buffer updates, or when it does an entity added, so what we need is a protected dictionary. I think entity.id is a UIT. Okay. It is from uint to entity position. Why would I do that? Why? Okay, so let's look at our little suggested text here. So I have set up protected dictionary UN to entity position, and I did a close bracket. That means I've ended the name escapes me, but I've ended the kind of variable type. And I defined its name. Its suggestion, and it's very insistent about it, it will not give me other IntelliSense because of this, is that, oh, what I meant was an entity position buffer. The class that I'm defining, I'm creating a dictionary of them inside of it. Hooray for recursive definitions, something you should avoid doing where possible, you know. We don't make linked lists as often anymore, so let's not keep doing that kind of thing. And it wants it to be named something else with an end semicolon, but I have following text after this. What's it going to do with that? No, just no. But guys, trust us, Copilot is super cool and you should use it. I do not use AI assistants in the code. I like when I ask a question and if you change the sentence ever so slightly, you will get completely different results despite the structure and like grammar of the sentence, that kind of thing, means the exact same thing, but the query results in something else. Like the AI summary is wildly different. Okay, so we have entity positions. We are going to add that entity ID in there. Okay. Entity. The entity position. Yes. Then we are going to say entity position dot updated equals in general. I found that the summaries are a useful kickoff point. I feel like for the health of the internet in general, it needs to focus on giving you the links with the reason for the link. Like, this one tells you about this related to your query. This one tells you about this. Their current model does not encourage you to go to the site, which discourages the existence of the site. The business model of sites requires them to be visited. If people don't go there, then the expense of running the site, the value proposition becomes negative. So why would somebody spend the effort of updating a site if they don't actually get traffic to it? On and on and on. It is the art encoding issue. Is they are dependent on the generation of new and quality materials to expand their learning sets. If you are not generating new quality material, then your training data stagnates, or worse, incorporates existing data and reinforces existing knowledge. Which means, you know, if your bots are creating art with Cthulhu fingers, then eventually the tags for art without Cthulhu fingers all like predominantly have art with Cthulhu fingers. That is no longer a flaw, that is a truth. It is no longer a hallucination, it is what it's based off of. So none of the methods for mitigating a hallucination would work against that. And I've been using hallucination in those sentences, but better is failure. Why are... Updated. Entity position. Whenever we get an entity position update message, we are going to get data span. Position data. So then data span e dot entity dot id is equal to no. Data. Okay, so whenever we update the position, we do this. Whenever we add an entity, we do this. A object sender entity remove entity message E. Okay, if there isn't an entity, none of this stuff happens. So when we create an entity position, no, entity positions always need to have one. Entity position data is clearable. Okay. Don't need to do that. Don't need to do that. Get the span. Say data span e dot entity dot id as integer. This purges the data out, which is going to zero everything, including like collidable position is 0, 0, that kind of stuff. Is it ideal? No. But most of the stuff that's going to operate on that is going to be looking at if it's collidable or not, or will not be asking about that entity. There may be more that we need to add accordingly. We might need to add the active Boolean, that kind of stuff. Cross that bridge when we get there. We remove the entity from the collection, and then we are going to need an attach entity events. Void entity position, entity position. Then we have this as a mirror to it. Detach. Entity position events. We say minus equals. Okay. So we detach the events if the entity position says to remove. Which will then give us this entire buffer. We can then attach to another event type, which is going to be protected void. Okay. So then we need I emits services resolve if physics start. I emits physics done. Services physics done. This on physics done. So what we're doing with these is what? So what we're doing with these is this is where we update stuff. Right now, this does nothing. I feel like we're going to need this. Minus, and we're going to move you up to here. So when physics starts, that's when we're going to update the buffer. Okay. That in there. So the next thing I would need to do then is in our services, we are going to add another. So we have compute related. We are going to add the render device. This is going to be part of compute because it is part of shader. Not a shader buffer. This is going to be a big long name, but meh. Protected render device. Oh. That's it. This is all this one does. Get the render device. Implements local render device manager. Actually implement it. We are going to need to be cautious about this one. Because again, these are picky about when you invoke them. because we can't wait to get this. This one, I think, needs to be a static class such that it gets invoked at the start and sticks around, because we don't want this render device to be created outside of the physics step. We are going to need to be very aware of this. This is a fiddly one. So say get set, return the render device. Yes, yes. Remove you. Get. There we go. Okay, so in the local rendering device in the shader collision manager, we're going to be setting that up somewhere in here. We need to fetch it from the here, rendering server, create local rendering device. Local. Actual rendering device. Most things are RIDs. It's the right terms. Constructor, local rendering device manager. Do I actually need to purge that one? Doesn't seem like it. All right. All it does when it's created, it's set up there. Boo. Very well. Okay, we have our rendering device now. So so let's start getting these into the services. Okay, so we've got that one. Goat, say I. So now we have the entity position buffer and the local render device manager, which means in the local render device, the entity position buffer, we can get our rendering device on when needed. Local render device manager dot rendering device. Oh, what did I call that? Or what is that called? Shader file, collision shader, buffer. Storage buffer create. Create entity position data. Entity position data. So using this data, then whenever we get a physics start, we are going to get the rendering device again. We update the buffer, which we will again pull from here. The buffer, entity position data and size, and data in content. As soon as physics has started, the data is... So now we need to know to... So we updated the buffer. Okay, no, we just need to update this buffer. That's fine. So this buffer now should be encapsulating all of the information we need. We're going to call that a collidable changed. Ugh. That... This is accurate, though. Okay. I don't... It's not great. We'll deal with that later, maybe. We'll deal with that later. The battle cry of the project manager. Okay. So now we have the entity position data buffer, which is what we need to pass into the collider. Let's... we added the entity position buffer to services. Okay. Hey there, Laura. We are deep in the weeds. Are we going to finish this today? Oh, probably not. I have every expectation that this is going to blow up in my face. Manager dot rendering device. And you, and you, and you. We are now going to do this, which is a little bit of shenanigans. Solve my local rendering device manager, rendering device. Bunch these little guys into play. Spiral outs can be kind of fun. Okay, collision's happening. This is good. I'm going to check the Godot side. We'll have to verify some of that. But this is all very subject to change. And that's in the flow generator, which is... it's not really a concern. That is something that needs to be heavily revised. I once knew somebody that was very pedantic about abbreviations. And one of the ones that they always got set off on was ID, like identification or identifier kind of thing, because it's a truncation. It's not an abbreviation. It's not a acronym. So frequently it will be ID, like capital I, capital D. But since it's an abbreviation, slash truncation, you know, it is it's I, capital I, lowercase d, or, you know, lowercase both, how dependent on where it shows up in your variable names and what your naming conventions are. Okay, so we are now using the rendering device. The next step is messier. Okay. So we have our buffer here. So right now we've got our collider data bytes and our collider data size, all of that, and our collider buffer. It's not what it's going to be. Okay. So we're looking for our collider buffer. Let's find the locations where it explodes. We do not do this or this. Our collider buffer we're going to get here. Okay, first we need to go up to this. We are going to restore it, and we are going to change its name to collider buffer. Then we remove it. So now we have updated the name. When you're working in programming, a very healthy rule when it comes to programming is it's when you enter a file, like one of these, whatever the conventions are inside that file, as long as they also conform to the organizational rules, you don't touch it. So if all of the identifiers are named capital ID, you leave them like that. If they're using 3 space tabs instead of actual tabs, you use 3 spaces. Because that is holy war territory. That is snide backhanded emails for days and days, if not indefinitely, if people keep trying to change those to whatever they think it should be. Okay, so we have our rendering device being retrieved. Now we need our eye. Okay, so we have RID, collider buffer. Is I entity position buffer dot get buffer. Okay, and then that will complain in our one buffer, which is the entity position buffer, where we're doing get buffer, but instead is going to be a get, which returns this. Then in our shader collision manager, we just say it's buffer. Okay. Probably gonna need you again later. when we copy that, delete that, go into the entity position buffer, and in our destructor, we get the rendering device, we get rid of the buffer when we are deconstructing, because these are transient, and they aren't freed automatically. This rendering device needs to get rid of it. So, build again. Let's make sure it still works. Okay, not set to an instance of an object. We have the device. We have a collider buffer. We do not have collider data bytes. But we won't have that because we don't update the buffer here. Okay, 2 things have gone wrong already. Let's try to hunt it down. Update collider data. Okay. Okay, Shader Collision Manager isn't the one updating the information anymore when entities are added. That's all in the buffer. Yeah, we don't do this anymore. We don't do this anymore. We don't do that anymore or that anymore. Or that. Or this. Because all it cares about is the buffer. Yes. Is working. Well, theoretically working. The collision isn't working now. Godot side. No errors being emitted here. Okay, I think I know where we're getting some of the issues. Okay, so when we are done, it's interesting. Again, this is one of the elements where this is actual development happening. And it's not that I would want to discourage people from getting into game development. It's that there is an impression of game development that it is all just like, you know, the art and the intent. And there's more to it going on than that. Now, there are tools out there that expedite the process for you. You don't have to learn, like, you don't have to code in machine code. You don't have to write your own graphics drivers, that kind of stuff. You don't need to use the most impressive systems, which lets you do things like built-in level editors and whatnot in Unity and Godot and that kind of stuff. You can hit the ground running with this, but after a point, there is a lot of work going on under the surface of the water. You know, the swan seems to move gracefully, but it's doing a lot of work under the surface to keep to move comparatively. Well, yes, it's the whoever's making the art is doing the art, but that's one part of it. We are computing. It's on a different on step. It is on a game start step. If we're computing, we're getting the rendering device. We get the variables. First, we're going to see if any collisions are actually being registered. We're just going to run at them here. You just need a mouse to touch one of them. Okay, no collisions are being registered. So the next thing we want to look at is in our position buffer in here. As well as in here. Okay, none of these are being updated. Okay, which means the entity position is not registering. Oh. Spot the issue. It's a dumb one. It is a foolish one. Yep. It is an iterative process. Okay, so to see if you guessed correctly, you see how I have all of these attach events and all these important events that need to fire so that the data gets updated? You see how it says 0 references to attach events? Oh. Okay, so we try again. Okay, it's a start. We're still not getting the events properly. So we need this one. And this one. And we also want... on physics start in there. That never fired. Which means we never fired it. On world steps done. No, invoke physics start. So did we forget to connect to it? We did. Same issue. Okay. Need entity events and to attach physics events. Okay, and then an entity position. We're calling all the methods. Debug, debug, debug. There is no I emits physics start, but services should have. Does not have an I emits physics start. Okay. Still no collisions. I could have just paused and added the brakes. To make sure entity position updated is happening, we need to make sure that our physics start is actually running. Oops, no, there's our problem. We are potentially purging the data over and over. Right here. This is... We're recreating the buffer each time. That can't be good. Yeah, we just need to create it the one time. We'll see if it happens while we're watching this time, but it is possible for things to get through the wall. Dependent on how they're moving, we still have the possibility of flawed logic in here. Okay. Okay, there is nothing in the entity position data. Thousand objects, entity position. So we're going to say data span of entity ID 3 is equal to this data, which has a position. It's collidable. It's category 4. So that is the entity position updating. And we just updated the data. Okay. Oh, wait, no. We get the collider. Okay. We weren't setting the entity on the collider. We are creating a collider of the appropriate type. We set it to the entity. Now that collider is going to load all of the relevant data from that entity. That's not ultimately how I want that to work. We have collisions once more. Will it purge enough of them? For reference, the extra icon that I've added here is bounce. Like a lot of the effects, bounce and pierce actually increase the health of the bullets. The health mechanic is that there are a series of objects called hearts in the entities. When an entity is struck, heart messages, or entities can receive heart-related messages, health-related messages. If a bounce heart receives a damage message, it will eat that whole message and apply movement to the entity and say, you need to move, you need to switch directions. When a pierce heart gets damage messages, it consumes the whole message and goes away. That means that when an entity would otherwise go away, when a bullet would normally vanish because it consumed a hit, that hit that it itself emits, it would normally go away, but because there are those intervening hearts, it stops that from happening, which also creates some interesting dynamics if you add other things, because the order matters with those. If towards the end of the line I added something that says this, like if I add pierce, it pierces before it bounces. Dodging the ads, huh? Anyway, this should continue to allow them to knock out more and more of the entities. Okay, now we look at it from the Godot side. No errors happening. We are going to once more flood the world. This will help them fan out a little. Okay. It does create interesting patterns when this happens, doesn't it? I like how you have the little spawner blob, the placeholder sprite for the that little bouncing blob there is not an actual enemy. It's what causes the ring of enemies to appear. But you can see that one little guy kind of hopping out of the mass. So this is an icon. This is from when we were using lower resolution icons, is why it looks so different. But this applies a random direction vector to it. When one of these guys comes into existence, it just kind of spins the wheel and says, you need to go that way, which is pulling on its existing direction. So it's trying to track an enemy. It's simultaneously trying to move in a random direction, and it's trying to orbit the player. So we will get a very distorted series of events because additionally, track an enemy just picks a direction and moves that way if it doesn't have a direction already. So we get this very dense circle that has, like, it'll have like distortions around the edges. And the reason that it's swinging around like that is the orbit logic. Is they are pulled into an orbit of a particular radius. So if I am moving away, the position that they want to be in is also moving. If they were noticeably faster than the player, then they would be able to keep up. But one of the aspects of the movement system is that the more types of movement there are that apply a vector, the more they share with the other movements. So there is the homing motion, the S-curve motion. I think this does apply a vector. So the homing motion, the curving motion, the random motion, and the circling motion, that gives us the 4 different movements. Each of them gets 1/4 of the time allotment. So the more of them you add, the more kind of diluted their effects get. They get kind of merged together more and more. That makes the speed of the entity consistent. It prevents the entity from speeding up, essentially. Now, they can speed up. That is a thing that movement types can do, is they can increase the movement, they can allow either the rest of movement that happens after them, to speed up, or that individual movement can be faster. Orbiting motion is actually faster than other motion because there's a lot going on. Conversely, if we put spiral motion is, because I don't have it fixed yet, is actually slower. Because it's not using the newer logic. I would need to update it. So you look at how like in a straight line, how they are moving. If I take that off, now there's the homing is more visible here, but they will definitely get through the blob and try to curve back around. See how much further this one is getting during its lifespan. So the spiral is not accounting for how motion goes otherwise, or the loop, we'll say. But yeah, we did a thing. Now, what does this get us for our next target? Like I mentioned, one of the things that could be happening during this stream was a bit of demo work. We have already, heading into this, we addressed the baseline issue. What we've done here is make it so that there is a single entity for the position buffer. This exists external of the collision logic. We can then do things like have a provider for the collision data if we wanted. But more importantly, this buffer, if I can use this same buffer in multiple shaders, I can make sure that this same buffer is updating at the relevant pace without each thing that touches it or without having to have multiple things recreate this sort of logic. Anything can just say, hey, position buffer, give me this information if it needs it. If they need the buffer, they can get that information. And for the most part, it's shaders that need this, and that's expected. The next thing we're going to be doing is, for now, creating a separate shader that is going to itself have its own cycle. So we're going to do the avoidance as its own thing, and go from there. We are likely going to have another layer of services that are the things that handle the shaders. The, add job, okay, submit kind of thing. We will pull that out of these individual handlers because the same pattern happens. Is we have a uniform, here's the uniform. We have a uniform, here's the uniform. Will we have to wrangle more and more of this? Yes. We're going to start with just having it be its own thing, akin to how the collision manager is. But as we go along, there will likely be shader managers where you're adding data to them in particular fashions, and interacting with that one accordingly. Some of these will be absolute individual entities, like the collision shader is a thing. It expects this data to be given to it, and it will run as it would normally run. So when you say, hey, I'm creating a run of this shader, it expects you to, it will get the entity position buffer. It will get the buffers that it wants set up, and go from there. But it's retrieving that same entity position buffer that other instances would use. When we do the avoidance one, we could set that up accordingly. Then we can have an overall run these shaders kind of structure, and it can batch them all together and say, run all of these together. Or we can have separate batches, however we want to do that. But we are further and further encapsulating stuff. Are we using this anywhere? We're not. Cool. Another one gone. So the shader collision manager would eventually become the collision shader manager. And there would be a collision shader style object that we would create that encapsulates all of the shader work that this is doing. So the work groups, the max collision, all of that. And the result of that, the fact that we run the thing, that this is saying, hey, I want this one to be run, is a way to approach it. Again, for now, we're going to have these be their own things. We're going to loop back to running them themselves, having them be run in another loop at another time. But I do want to start looking at a state-based structure so that we don't have this exact pattern happening here. Is that we could essentially say, hey, the state is game step starting. We take that state object and we say, okay, you're in charge now. It is probably going to emit game step start. Subsequent things might call out and say, hey, switch the state to this. And to handle that, we're going to need stronger order of operations. Stuff is going to need to happen. But it allows us to wrangle some of this. We shall see. We shall see. But yeah, I think that's gonna be where we'll pause for the night. Target is tomorrow for the next one. We should be able to head into avoidance now that we've got that. We have some of the skeleton objects in place. It's going to remove the entity avoidance objects in their corresponding chain from this. So there will be simplification going on, which is great. So that will be creating the shell object for it, the service for it, and the corresponding shader. And we'll see how that do. Ideally, within the next couple streams, we will have all the blobs trying not to overlap when they are converging on the player. There's likely going to be some jitter when it gets when they get closer. There are going to be ways for us to mitigate that, but I'm not really worried about that too much. If there are so many things that they're jostling each other, then there are other problems than that visual effect happening. As in, loss is potentially imminent, and the problem will solve itself. But yeah, I hope everybody had a good time watching with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment, all that stuff. Those buttons generally help the channel, so I'd appreciate it if you press them. If you'd like to consider supporting the channel financially, you can do so through platform-specific means, as well as other options found in the links in my description and bio. In my video descriptions and bio. But with that, folks, I hope the rest of your day is good, and I will see you next time. When I find the button.